Okay, in this video let's solve an exact differential equation. Alright, on the previous video we checked that this one was an exact differential equation, but let's do it again. The first thing to identify is what is m and what is n. Remember, the m goes with the differential of x and the n goes with the differential of y. So what you have to do is to check that the partial of m respect to y is equal to the partial of n respect to x. One way to remember what partial you have to do is that this is differential of x, then you apply the other variable partial derivative. And this is the n goes with the differential of y, and then you apply the partial respect to x because it's a cross partial derivative check. Okay, so derivative of this respect to x is respect to y, sorry. Because it's a partial derivative, then the x is a constant, so this is going to be 2x. And the partial of n respect to x, here is very clear that the result is x, 2x. Because they are equal, then it is exact differential equation. So that means that this comes from the partial of a function respect to x, differential of x, plus the partial of a function respect to y, differential of y equal to 0. So that means that this is equal to this and this is equal to this. Okay, now the solution of exact differential equation is actually the exact function. So let me write that here. The solution is the actual function of two variables equal to a constant. So this is the guy that we have to find. So that is the task, to find it. To find a function of two variables such that the partial derivative respect to x is equal to this, and the partial derivative of the same function is equal to this. Alright, now, so because you have that the partial of the function respect to x is equal to 2xy, and the partial of the function respect to y is equal to x squared minus 1. So the obvious step is, if you get the partial derivative of the function respect to x is equal to this, then you take the integral partial of this, or respect to x here, or you can take the partial integral respect to y of this. Okay, so we have two options. Either we take the integral respect to x from here, or we take the integral respect to y from here. Now, I can tell you that either way you are going to get the same result. Okay, let's try this one. Let's try to find the function of two variables as the integral of n respect to x here, because it's supposed that the m comes from the partial of f respect to x. So the function of two variables is just the integral of m respect to x, or this respect to y. But let's try this branch. Okay, so because this is a partial integral of n respect to x, that means that the y is a constant. So y, consider constant for this partial integral. So be careful with that. So here is you are going to have the integral of the m is equal to 2xy respect to x. Let's take outside the constants, and the constants here are 2y, integral of x respect to x, and the integral of this is going to be 2yx squared over 2. So the 2 and 2 cancels. Okay, but every time you take the integral, then you have to add a constant. Okay, but be careful here, and this is very confusing for the students. If you add a constant, remember that the y was considered a constant, and because it was considered a constant, then this constant could be a function of y. Alright, a function of y. So the problem becomes the function of two variables is equal to x squared y here, because the 2 cancels, plus h of y. Now, if you take the partial derivative respect to x, you are going to actually get this, and the partial derivative of something that is only function of y is going to be 0, which is here. Okay, now the task is what is h of y? Could be 0, could be a constant, or could be something as a function of y. We don't know yet. So let's find out the h of y. And to do so, what we are going to do is to take the partial of that function with respect to y, and that should be equal to my n. Okay, and you can have it here. You can see it here. The derivative of this function must be equal to the n. Okay, so let's do it. The partial of the function that we just calculated respect to y is equal to the derivative of this respect to y, partial derivative respect to y of x squared times y plus the partial derivative respect to y of h of y. Okay, be careful here because here I don't have problems to take the partial derivative. Derivative of this, because x is a constant, can be taken outside, and the derivative of y respect to y is equal to 1. So this is equal to x squared only. Alright? But let's be careful here. Now you have a partial derivative with respect to y of something that is only function of y. So this derivative becomes normal derivative plus normal derivative of h of y with respect to y, or ordinary derivative, because this function of y is only function of one variable. So functions of one variable don't have partial derivatives, they have ordinary derivatives. And because it's the same variable, then it is normal derivative. It's not 0. Okay, now this is supposed to be equal to my n, and the value of n happens to be equal to x squared minus 1. Okay, now we are going to work with this side of the equation. Remember, what are we looking for? We are looking for the h of y. What is that value? Which is the only thing missing from the exact function. Okay, now from here I can see that this and this cancels. So the derivative of h of y respect to y is just equal to minus 1. So what is h of y? H of y is equal to minus differential of y. Here differential, and you take the integrals because it is a variable separable differential equation. So h of y is equal to just minus y plus the constant. Now this constant is a normal constant because it is a normal integral. Alright, no, it's not a partial integral. Okay, so what you have here is the solution. The function of two variables equal to x squared times y plus the h of y that we just found, minus y plus the constant. Okay, here a small step, because the original function is an exact function, then this function of two variables must be equal to a constant. Now here we have two constants. This constant comes from the integral, and this constant comes from the definition of an exact function. There is no need to write two constants, so one constant is enough. Okay, so what you have here is x squared y minus y equal to a single constant. Now this is an implicit solution. If you want to have the explicit solution, you just clear the y, and the y is equal to c over x squared minus 1. And this is the solution of the exact differential equation. Alright? Okay, engineers, just to reconsider the steps. The exact function, you have to make sure that this happens, then it is an exact differential equation. Once you check that, then you can do this. Now you have two branches, you have two options. Either you take the integral respect to x, or you take the integral respect to y. In this example, I went through the integral respect to x, alright? But here is going to generate a constant that could be function of h of y, and that is the next step. What is that h of y? We are going to find that h of y with the other one, alright? And here is the process, alright? I'm going to repeat the same problem. If what happens instead of choosing this one, we choose this one, to integrate first this one. We are supposed to get the same result, and we actually are going to do it. So let's do it. Accept the final solution, because we are supposed to get to the same solution. Okay, so here, so what I'm going to do is, instead of taking the integral respect to x, I'm going to take the integral respect to y. So my function of two variables is equal to my integral of n respect to y, which is the integral of x squared minus 1 integral partial respect to y. And remember here, because it's respect to y, that means that the x is a constant. Because x is a constant, you can see that this is all a constant. So the result of this is you take outside of the integral this, and the integral respect to y is just y. So it's going to be x squared minus 1 times y. Okay, every time you take the integral, you have to add a constant. But be careful here. That constant, because it is a partial integral, we consider the x to be a constant. So this constant could be also a function of x. So the function of two variables that we calculated is x squared minus 1 times y plus h of x. Now, if you take the partial derivative of this respect to y, then you get this one, because this is 1 and this is 0, because it's only a function of x. Okay, now, what is that h of x? That is the question. So we are going to calculate h of x, because we don't know what is that value. Okay, now, to do the calculation of h of x, we are going to use the other fact. The partial derivative of this respect to x happens to be equal to my n. So let's do it. The partial of the function of two variables. So let's take the partial derivative of this respect to x. So the derivative of this is going to be 2x and y plus partial derivative respect to x of h of x. And here comes the same as in the other branch, because you are taking the partial derivative of a function of one single variable. Then this is no longer a partial derivative. This becomes a normal derivative. Okay? And because they are of the same variable, so it's not zero, so it's normal. It's just a normal derivative. And the partial of the function respect to x happens to be equal to m, because this is equal to m, then this is equal to 2xy. Okay, so we are going to work with this side of the equation, because remember, we are looking for the h of x. So, as you can see here, this and this cancel, so the derivative of h of x respect to x is equal to 0. Now, what could be the function of h of x such that the derivative is equal to 0? Well, the answer is very straightforward. H of x must be equal to a constant, so that the derivative is equal to 0. So that means that for this branch, h of x is just the constant. Okay, so the function of two variables. So the function of two variables is equal to x squared minus 1 times y plus the constant. But here comes the first concept, that the function of two variables is an exact function. So that means that it is equal to a constant. Now, there is no need to write two constants. One constant is enough. So x squared minus 1 times y equal to a constant. So this is the implicit solution, and the explicit solution, you just clear the y, and then it's going to be c over x squared minus 1. As you can see here, we got the same result as we did in following the integral respect to x. Okay, so this is the method to solve an exact differential equations. Okay, you can choose this branch or this branch, but the result is going to be the same. All right, I usually check which one is easier to take the integrals, and I choose that branch, but in the end it's the same result. All right, next video we are going to cover what to do when it is not equal. What should we do when it is not equal? All right, see you.